Hi everyone, I am Dr.J.BHUVANA, Assistant Professor of Chemistry, A.D.M.COLLEGE for Women, Autonomous, NAGAPATTINAM. Today, we are going to discuss about molecular rearrangements. This chapter belongs to 3rd BSc Chemistry in Organic Chemistry course. What is meant by molecular rearrangement? In organic chemistry, a rearrangement reaction is a broad class of organic reactions where the carbon skeleton of a molecule is rearranged to give a structural isomer of the original molecule. Often, a substituent moves from one atom to another atom in the same molecule. A rearrangement is not well represented by simple and discrete electron transfers. Rearrangement reactions are a type of chemical reaction in which a compound is rearranged by moving its atom within the molecule. It is a product creation through rearranging atoms in a different order. The reaction of these components has great importance in organic chemistry and it is also critically required in the synthesis of different organic compounds. It also refers to the relocation of atoms or groups of atoms inside a molecule so as to obtain a new final substance. The reactions can consist of a single molecule site or occur between a couple or multiple molecule sites. Such processes are driven by a response leading to the stabilization of the rearrangement of atoms, usually in the form of the formation of more stable electronic configuration or molecular structure. This term, rearrangement, is used to describe two different types of organic chemical reaction. One is a rearrangement may involve the one-step migration of an hydrogen atom or of a large molecular fragment with a relatively short-lived intermediate. On the other hand, a rearrangement may be a multiple-step reaction that includes the migration of an hydrogen atom or of a larger fragment as one of its steps. This is about general introduction about molecular rearrangement. Next, we have to know about the types of molecular rearrangement. There are two basic types in molecular rearrangement. They are intramolecular rearrangement and intermolecular rearrangement. So, what is meant by intramolecular rearrangement? It is the transition takes place within a single molecule on the other. This is called intramolecular. What is meant by intermolecular? Where atoms or groups shift from one molecule to another. That is called intermolecular rearrangement. A rearrangement reaction is one in which molecules break and the bonding is rearranged in order to attain the new structure, keeping its number of total atoms unchanged. Some other types of rearrangement reactions. Let us see one by one. First one is carbocation rearrangement. This rearrangement occurs via a carbocation intermediate formation. While during takes place the reaction, the intermediate is formed. That intermediate is carbocation intermediate, where a shift of hydrogen or an alkyl group happens happens to form a more stable carbocation. Another type rearrangement, nucleophilic rearrangement. In nucleophilic rearrangements, a nucleophile induces the migration of an atom or group within the molecule. This is called as nucleophilic rearrangement. Next type is electrophilic rearrangement. Here, an electrophile induces the migration of atoms or groups. Often, electrophiles like protons can create carbocation intermediates that facilitate the rearrangement. Next type, sigmotrophic rearrangement. These are pericyclic reactions involving the simultaneous shift of a sigma bond and pi electrons. The atoms involved in the arrangement move along with the migration of electrons. So, here we discuss about the introduction and the basic type and the general types of rearrangement. Let us learn about one by one the molecular rearrangement. First, we take pinnacle-pinnacle rearrangement. What is meant by pinnacle-pinnacle rearrangement? It is a acid-catalyzed rearrangement of 1,2 diols. That means vicinal diols. The acid serves to protonate one of the hydroxyl groups which it deposits as water, giving a carbocation. Subsequently, a pi bond is formed as carbon-carbon bond migrates to the adjacent carbon. It resembles the familiar hydride shifts and alkyl shifts in that a less stable carbocation is converted to a more stable carbocation. That more stable carbocation is actually the resonance form of protonated ketone. So, pinnacle rearrangement can result in ring expansion. What is the reaction? When pinnacle is treated with a strong acid such as sulfuric acid, a new ketone is formed and a molecule of water is lost, forming the diol. Upon inspection, it has been seen that the carbon skeleton has undergone rearrangement that is described in this slide. Pinnacle rearrangement is a special case of carbocation rearrangement where migration of a carbon is accompanied by formation of a new pi bond. The product is a ketone. The pinnacle rearrangement is promoted by the addition of acid which assists in loss of water as a leaving group. Next one, the rearrangement of pinnacle-pinnacle occurs through the following stepwise mechanism. What is the first step? Since the reaction is carried out in acidic conditions, in this step, a proton or hydrogen ion, that is H plus is released from the acid. Usually, sulfuric acid is considered. It breaks down to form an H plus cation and a sulfate anion. The cation thus released is attached to the hydroxyl group present in pinnacle. Therefore, the hydroxyl group in the pinnacle is protonated. Step 2. What is step 2? A carbocation is formed. In this step, the bottom molecule detached from the compound and result in the formation of a carbocation. This carbocation is of tertiary type and hence stable, but it has a chance to get more stability. What is step 3? Migration of the methyl group. occurs in this step just to make the intermediate more stable. The methyl group shifts from one carbon atom toward another. Positively charged carbon atom is produced. What is step 4? This step is the deprotonation step. The protonation which occurred in step 1 is now headed towards deprotonation. The proton which kept attached to pinnacle initially now detached from it, resulting in the formation of pinnacle as the final product. So this is the pinnacle rearrangement. Next, we came to know about benzylic acid rearrangement. What is meant by benzyl acid rearrangement? It is the conversion of benzyl into the salt of alpha hydroxyl acid in the presence of an alkali base. The reaction of 1,2 diketones with alkali hydroxide and produce alpha hydroxy carboxylic acids. So what is the mechanism? Nucleophilic addition of the hydroxide anion to one of the 2 carbonyl groups initiates the reaction. The corresponding substituents are attached to the carbonyl group in which hydroxide anion attacks, then move or migrate with the bonding electrons to the neighboring carbon atom, resulting in a 1,2 shift. Finally, a proton transfer caused the carboxylate anion to form. What is the mechanism? Stepwise we have to follow. This reaction occurs in 4 ways. What are the 4 ways? First one, step 1, nucleophilic addition. In this step, base OH attacks on one of the carbonyl groups of ketone and nucleophilic addition takes place. What is step 2? In this step, 1,2 phenyl shift takes place. Next, step 3. In this step, intramolecular. Remind the word intramolecular. Proton shift takes place and a stable ion is obtained. Step 4. In this step, the carrying oxygen atom abstract the proton to form alpha hydroxyl carboxylic acid derivatives. So this is about benzylic acid rearrangement. Next, we have to study Claisen rearrangement. The Claisen rearrangement is an organic reaction in which an allyl vinyl ether or an aryl ether undergoes a 3,3 sigmatrophic rearrangement to produce unsaturated carbonyl compound. This reaction facilitated by the addition of heat or in the presence of Lewis acid. This reaction is also an intramolecular concerted process where bonds break and form at the same time. The Claisen rearrangement is essentially an irreversible process since the products are considerably more stable than the reactants. The electrons are pushed around the 6-membered ring in an electrocyclic process. The resulting dienone now undergoes tautomerization to give its aromatic enol form. This form is more stable than the dienone form. The required compound is formed. Thus, the required delta and gamma unsaturated carbonyl compounds are generated from the Claisen rearrangement of allyl vinyl ethers or diphenyl ethers. This rearrangement reaction is exothermic in nature. As discussed earlier, the reaction mechanism is concerted. That means the reaction kinetics of this rearrangement is of first order. The reaction is only accelerated by polar solvents. Hydrogen bonding solvents provide further acceleration of reaction speed and a greater rate constant. The conversion of allyl ethers to allyl phenols on heating to about 200 degrees centigrade alone or in the presence of some inert solvents like diphenyl ether. Allyl group migrates to the ortho position. If both the ortho position are occupied, then migration occurs to the para position. So what is the mechanism for this Claisen rearrangement? Step 1. A cyclic transition state is formed in the first slow step. Step 2. It forms an intermediate. Third step. It undergoes ionization in a fast step, giving the product. And next rearrangement is Fry's rearrangement. What is meant by Fry's rearrangement? Fry's rearrangement is an organic rearrangement reaction in which an aryl ester is transformed into a hydroxyl aride ketone with the help of Lewis acid catalyst and an aqueous acid. In this reaction, an acyl group belonging to the phenolic ester migrates to the aride ring. It is important to note that Fry's rearrangement is ortho and para selective. The acyl group attaches itself at the ortho and para position of the aride ring. The selectivity of the reaction can be directed by modifying the reaction conditions such as the temperature under the reaction is conducted or the solvent used in the reaction. What is the mechanism for Fry's rearrangement? Initially, the carbonyl oxygen belongs to the acyl group, forms a complex with the Lewis acid catalyst, usually aluminum trichloride. The formation of the complex with the carbonyl oxygen is favored over the complexation of the phenolic oxygen since the carbonyl oxygen is richer in electrons and is therefore a better Lewis base. Now the bond between the phenolic oxygen and the acyl complex become polarized, resulting in the rearrangement of aluminum trichloride bond to the phenolic oxygen. This results in the generation of an acylium carbocation. The acylium carbocation goes on to the attack of the aromatic ring via an electrophilic aromatic substitution reaction. It is important to note that the orientation of this electrophilic aromatic substitution is temperature dependent. Low reactions temperature favors substitutions at the para position and relatively high temperature favors ortho substitutions. Aluminum trichloride complexes with the oxygen of the phenoxy group is combined. Thus, acylium ion is generated. Acylium ion then attacks to the benzene ring and form the product ortho and para acyl phenol. In this rearrangement, both intermolecular and intramolecular mechanisms are operating simultaneously. So, in this session, we discuss about what is meant by molecular rearrangement, what are the general two types, intermolecular and intramolecular rearrangement, and some other types, electrophilic, nucleophilic, carbocation rearrangement. Then we discuss about 4 types of rearrangement phenol, phenochlor, glycine, benzyl benzoic acid, and the Fries rearrangement. Thank you.